Alright, we are in geometry. Today's date is Wednesday, October 2nd, 2019. Today we're talking about surface area with nets. I am currently at a teacher meeting with other math teachers from all around the area, so that's why I'm not here today. Before I talk about our objective and start with the notes, I want to give you a brief outline on what's happening this week. So I made a minor modification. I know at the very beginning of the week I said that there was going to be no quiz, but that has changed. So you might notice that my unit guide looks a little bit different than yours. We used to have 1-19 on Friday, but notice that there's no 1-19 anymore. It jumps right into a quiz, which means quiz 1.4 on all of this stuff, area, circumference, nets, stuff like that. That is all going to be quizzed on Friday, so be prepared. I know that we'll still have Thursday to talk about surface. There we go. The point of this lesson is to prepare you for tomorrow's lesson, 1-18, where you do not get a net for the homework. So on the homework night, I'm always going to be providing you with a net, so I'll give you a net, and then tomorrow you have to make your own net, so be warned. You need to know how to make your own net. But yeah, let's talk about our objective. We need to find the surface area of prisms, and pyramids using nets. So before we even begin, let's talk about what is surface area. Surface area, I like to think of if I'm wrapping presents, how much wrapping paper do I need if I want the minimum amount of wrapping paper? Or if I'm using paint, how much paint am I going to use to paint the entire shape? It's the area of this face, the bottom face, the back face, the front face, the side face. Add all that up, that is the surface area. I think you probably have seen that before. I didn't even write it down. But a prism you might not know the definition of, because we're talking about prisms and pyramids today. And you might say, oh, Mr. Sindel, I know what pyramids are. I've seen Egypt. You might not know the mathematical definition of a pyramid, so I'll be giving that too. So a prism is a polyhedron. This is a fancy word that says a 3D shape. If you don't like the word polyhedron, just convert that in your mind to a 3D shape with two congruent faces, and they should have flat sides as well. So our congruent faces, and I guess for this shape you have quite a few congruent faces. You have the front and the back, you have the left and the right, you have the top and the bottom. Those are all congruent faces, so this is definitely a prism. And the name for this, you do need to write it down, is a rectangular prism. Rectangular prism. It's usually the most common prism because it's really nice for finding volume. You just do base times, or length, width, height, I don't know what dimensions you want to call them, but they're really easy. You just multiply them together. This guy is not that easy, but it has a nice name. It's some sort of prism. You want to take a guess at the name of the prism? Look at that face. Look at that. It's a triangle, so it's a triangular prism. Triangular prism. Take a guess at this one. It's another prism. Anyone want to take a guess for the first word? It's 1, 2, 3, 4, 5, 6 sides for the base here. And the base is a hexagon, so it's a hexagonal prism. Hexagonal prism. Okay, so now you know prisms. Oh no. Teacher error. Okay, I guess I need to give everyone 70 XP. Remind me to do that. And this should say pyramid. That's my bad. Pyramid. So a pyramid is a polyhedron. Again, if you don't like the word polyhedron, think of 3D shape with a base and what type of faces that meet at an apex. So I'm going to call this thing right here the apex. You can just think of it as a point. It's the point where all of these faces meet up. Notice that each of these faces, well, before I do that, each of these bases is a different shape. I have a square, a triangle, another hexagon. So they have different bases, but notice that the lateral faces, this face, the face in the back, the face on the left, I call those lateral faces. Each of those faces is what shape? Each of these faces is always a triangular face. Triangular face. And they all meet at an apex. So that is the definition of a pyramid, and you probably are used to seeing a square pyramid, so let's write down name for you, square pyramid, because that's what you see in Egypt. This one is less common. You can call this a triangular pyramid. Triangular pyramid. And if you have the unique fact that all of these lengths are the same, then that would turn into a tetrahedron, but we'll learn about platonic solids later. And yeah, you should be able to do this just based on the last question. It's some sort of pyramid. And if you're screaming at the computer, it's a hexagonal pyramid, you would be correct. You just use the same word, hexagonal. Hexagonal. Cool, so now we can talk about shapes a little bit more formally. Now let's talk about nets. So you've seen nets before. You have seen them maybe in 7th grade or 8th grade or both. It's some 2D pattern that can be folded into a polyhedron. Again, polyhedron means 3D shape. And it is extremely helpful for finding the surface area because I can find the area of composite shapes because that's what we've been doing. So in example 1, I want to find the surface area of this rectangular prism, and I'm going to use its net. So instead of having to somehow figure out, oh, I don't know what that is, I can tell it's maybe 2 times 3 and that's 6, but I'm like, oh, I don't know what is the area of that one or the area of that one. It's really easy because it's laid out nice and simple. So again, I will repeat this. As you're doing these examples, be thinking about how you can make your own nets or how you can do your own process for finding out the area. This one might be easy to do in your heads without using a net, but then they get harder and harder. How are you going to do these in your heads? So if I come in here, notice, I'm going to zoom in. So notice that this length is 3. If this length right here is 5, this length 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 is 5. All of them have a length of 5. So I'm going to write a 5 out to the side. If this length is 3, you can actually just count the squares, I guess. There's not that much trick. 1, 2, 3. This length is also 1, 2, 3, 1, 2. And this length is 3 by 2. We can find all of their areas now because the area of a rectangle is just base times height. So 3 times 5 is 15. 5 times 2 is 10. 5 times 3 is 15. 5 times 2 is 10. 3 times 2 is 6. 3 times 2 is 6. And I add together, maybe I should circle them. These are the areas. I add together these 6 areas. There is a quicker way of doing these, by the way. It's about circle. The quicker way of doing that is just to figure out this giant rectangle all at the same time. You know that's 3 plus 2 plus 3 plus 2, so that's 6 plus 4, which is 10. I know this whole length is 10. 10 times 5 is 50, and we can actually check that. 15 and 15 is 30, 40, 50, so I have 50 plus 6 plus 6, and I get 62. So if I come over here to the right, I can say this is 62. And do I have units on here? I don't, so I'm just going to say units. And because I'm talking about area, it's units squared. Final answer, box it. And that's how you're going to be doing each of these. So that's too much. I come back down here to example number 2. Let's find this surface area. And then I think, yeah, you can do example 3 on your own. Let's do example 2 because they're triangles. We might need to review those. So if I come in here to example number 2, this is the original shape. Notice how it gets converted into a net. Could you do this on your own? Could you convert this into a net on your own? And then once we have the net, it's as simple as multiplying. If this length is 7, this length is also 7, and 7, and 7. All of them are 7. So I can label that as 7, that is 7. And then we can just start multiplying. So I'm going to do this in red to say that's area. 3 times 7 is 21. 6 times 7 is 42, and 3 times 7 is another 21. Again, the shortcut being this is just one giant rectangle. If you do the giant rectangle, 3 plus 6 plus 3, that's 12. 12 times 7 is 84. So this whole rectangle, I'll make a note here, that giant rectangle is 84. And we can check that, add them all up. You know, yeah, that equals 84. And don't forget your triangles. So this triangle is we'll write down the formula for a triangle in case you forgot. The area of a triangle is equal to base times height divided by 2. Cool. So base is 6, height is 2. 6 times 2 is 12, divided by 2, and you get 6. So this area down here in red is 6, 6. So I need to add 6 plus 6, which is 12, to 84, and I get 96. So my final answer down here is 96 units squared. And they're that easy. So there are 2 homework assignments tonight. One of them is using the nets to find surface area. That's the hard part. And the other one is just identifying which nets go to which polyhedron. And that, I think, is even easier. If you guys struggle, though, we'll talk about it tomorrow when I'm back. What I want you guys to do now is do example number 3 all on your own. You're just using nets. You know the area of a triangle now. Do it on your own. Alright, you've unpaused the video because you've tried on your own and you just want to check your work. So you're playing me super fast and I sound funny because I'm going so fast. This is a 4x4, so that's an area of 16. That's a bad 6. This triangle here is 4 by 3 because this lateral area, or lateral height is 3. 4 times 3 is 12, divided by 2 is 6. So 6, 6, 6, and 6. So 6 times 4 is 24. Plus 16 is 40, so the correct answer here is 40 units squared. Final answer, and box it. A nice and easy lesson today. Again, don't write your summary. Wait to do that later. I will be checking off summaries, so make sure you have notes 1-16. Do that summary now if you forgot to do it. There probably will be a binder check tomorrow. Yeah, just a heads up. I'm doing binder checks in a lot of my other classes. Might as well do it in your class. You've been warned. That concludes the notes.